Okay, in this video I'm going to show you how to graph solutions to linear inequalities. So consider this linear inequality right here. So a point which has an x-coordinate and a y-coordinate solves a linear inequality if, when you substitute the x in for the x and the y in for the y, the inequality is true. So for example, if we consider the point 0, 1. So we substitute the y in for the y and the x in for the x, and we're going to see if it's true. So we substitute the y in, so we have 1, and we want to know if it's greater than 4 times the x minus 3. So 4 times the x minus 3 is equal to 0 minus 3, which is negative 3. So 1 is bigger than negative 3, so that is a solution to our linear inequality. Let's check the point 2, negative 1. Let's see if the point 2, negative 1 solves this inequality. So we substitute the x in for the x and the y in for the y. So is negative 1 bigger than 4x minus 3? So 4 times 2 minus 3. We want to know if this is true. Well, 4 times 2 is 8, so 8 minus 3 is equal to 5. Negative 1 is not bigger than 5, so that means that 2, negative 1 is not a solution to this inequality. Let's just check one more. Let's check, say, negative 1, 3. So we'll put the 3 in for the y. So we want to know, is y bigger than? So is 3 bigger than 4x? So 4 times negative 1 minus 3. 4 times negative 1 is negative 4. Minus 3, that's negative 7. Yes, 3 is bigger than negative 7, so negative 1, 3 works. So in fact, it turns out that we're going to have infinitely many solutions to this inequality. So the best way we can represent the set of all solutions is to graph the solution. Okay, so we're going to do that now. So the first step to graphing the solution to a linear inequality is to graph the line. Okay, so we're going to graph the line y equals 4x minus 3. Only since this says y is bigger than 4x minus 3, it means y is not allowed to be equal to 4x minus 3. So we're going to make it dotted. Okay, so we'll go to the xy plane. And I think the way that I like to graph lines is I like to find the x-intercept and the y-intercept. So remember, this is y equals mx plus b. So if you have y equals mx plus b, then b is your y-intercept. Okay, so negative 3 is our y-intercept. And to get the x-intercept, we put 0 in for y. So if we solve this, we get 3 equals 4x, so x will be 3/4. So around right there. All right, so as I said, we're going to make it dotted because y is bigger than 4x minus 3, not equal to. Okay, so you can see that this line here divided the entire xy plane into two pieces. So we have this piece on the right side of the dotted line, and we have this piece on the left side of the dotted line. So the solution to our inequality is going to be one of those two halves, or one of those two pieces. And the way that we are going to determine which piece includes all the solutions is we're going to pick a point that's not on the line. Okay, we're going to pick a point that's not on the line. We have all these possibilities. I know that that's the point 3/4, 0, and that's 0, -3. So for example, 0, +2 is not on the line. Okay, if 0, 2 solves the inequality, then the region containing 0, 2 is going to be the region we shade. So let's see. So we want to know, y is bigger than 4x minus 3. Is that true? So we substitute the 2 in for the y and the 0 in for the x. Four times 0 minus 3, that's going to be equal to -3, and 2 is bigger than -3. So it means the point 0, 2 works. So since this works, or I'll say in the case, so in all cases, if the point is a solution, shade the region containing the point. If it isn't, shade the other region. Okay, so our solution is going to be all of these points right here, but of course not including the line y equals 4x minus 3. So you see this point here, 0, 1, that we knew was a solution. This point here, -1, 3, so here's -1, and up 3 units, so that's a solution too. Okay, so all of this region here contains all solutions to this linear inequality. All right, we're going to do a couple more examples here. So we want to graph the solution to this inequality here. And so again, the first step that we're going to do is we're going to graph the line x plus y equals -1. But in this case, it says x plus y is bigger than or equal to -1. So if it allows for equality, we'll make the line solid. Okay, so again, I'm going to find the graph of this line by finding the x and y intercepts. So to get the x-intercept, we put 0 in for y. So we have x plus 0 is -1, so x is -1. And to get the y-intercept, we put 0 in for x. So if we put 0 in for x, we get 0 plus y equals -1. So y equals -1. So our x-intercept is -1, our y-intercept is also -1. Okay, again, I'm going to draw a solid line this time because this inequality allows it for equality of x plus y and -1. Alright, so here's our line. Next up, what we're going to do is we're going to pick a point not on the line. So I know that the point, say, 2, 0, 2, 0 is not on the line. So we'll look at 2, 0, and the question is whether or not 2, 0 solves this. So I put the 2 in for the x and the 0 in for the y. So 2 plus 0, we want to know, is that bigger than or equal to, actually, sorry, I'll put my question mark here, is that bigger than or equal to -1? And yes, 2 is bigger than or equal to -1. That is true, and so we're going to shade the region, including the point 2, 0. Okay, so that right there is the solution to our inequality. Okay, let's do one more. And I would like you to pause while you work on it. So y plus 2x is less than 3. So press pause while you work on this. Alright, so y plus 2x is less than 3, so we're going to graph y plus 2x equals 3 and make it dotted. So the y-intercept is going to be, so the y-intercept is when x is equal to 0. So we get y equals 3. And the x-intercept is when y is equal to 0. So we get 2x equals 3, or x equals 3 halves. By the way, if I got that the x and y-intercept were both the origin, then to graph the line, I would just find any other point on the line. All right, so plot these. Okay, so again, we're going to make this dotted since this is a strict inequality. All right, so now we're going to pick a point on a line. Let's choose, I know that that's 1.50, so why not? Why not choose 2, 0 again? So we'll look at 2, 0, and the question is whether or not 2, 0 solves the inequality. Okay, so there's 2, 0. And so we have y is 0, so 0 plus 2x. And 2 times 2 is 4, so 0 plus 4, is that smaller than 3? The answer is no, 4 is not smaller than 3, so this is not a solution, so 2, 0 is not a solution. So since it's not, we're going to shade the other region. So it's all of these that solve it. Okay, I'm just going to quickly point out, so we're done with this problem. I'm just going to quickly point out another way that we can do this that's an alternative to picking a point not on the graph. Some people can see it, others not. So the other way we can view it, again, we're still going to graph the line, but after we graph the line, we say, all right, let's look at this inequality. It's y is smaller than 3 minus 2x. So we graph the line y equals 3 minus 2x, and smaller than means we're going to go below the line. If it were y bigger than 3 minus 2x, we would have gone above the line. Okay, but it's not. It's y is smaller than 3 minus 2x. So again, some people don't really see this as above and below, in which case it's better to pick a point and see whether or not it solves it. Okay, but it's totally up to you.